Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will again look at the use of macros in your applications, this time tackling macro functions. In our last video on macros, we covered single-line macros and multi-line macros. Today we're going to be looking at macro functions. But for those of you who haven't watched the previous video, I'll do a quick recap. Macros are basically text substitutions performed before your application is compiled. They are effectively pre-processed. For example, on screen we have here a macro called mReleasePackage. What this will do when your application compiles is that it will replace the word mReleasePackage with the word macro. This allows us to create things on the fly before the application is processed. So we can set a macro called buildVersion and make it equal to the string releaseBuild. This means when your program actually compiles, the text in your code called buildVersion will be replaced by whatever the text you set up here. Macros can be a useful tool to make your coding less tedious, much in the same way as we use libraries of functions and subroutines. So in order to get the best out of our macros, we're going to create a library to hold them. I've created a library file called macro library as an include file, and all the macros we created in the last video are included in this file. So we're going to reference this include file at the beginning of our code, and we will move this single-line macro into our library. So now that we have referenced this library in our code, we can now go ahead and compile and run our application. And our application runs quite happily, displaying the release build version and the version number. The advantage of macros is if they are not referenced in the main bulk of your code, then they add nothing to the size of your executable, as these are text substitutions performed before the actual compilation. So what we're going to look at now are macro functions themselves. So first, we need a problem which our macro is going to be the solution. So let's say, for example, we have two strings of data, and we want to fold both of these strings in together so that the characters within these two strings are interleaved. So we have created some local variables to allow us to do this. A data1 string and a data2 string. The data1 string contains 4 letters, A, B, C, and D. The data2 string contains 4 numbers, 1, 2, 3, and 4. We want to create a macro function whose job it is to take the first character from the first variable and add on the first character from the second variable, and then work through each character interleaving as it goes. And the return from this macro should be the entire new interleaved string. And the output from this macro we will store in our output1 variable, which is a string. So our macro is going to be called foldString and will take two parameters, data1 and data2. And the output from this macro will populate our output1 variable. So let's go into our library and we will create this new macro function. As we did in the previous video, we're going to be passing the two parameters inside the brackets. But as this is a macro, we don't need to declare the type of the variable, as this is merely a text substitution process. So if we were to perform this task without a macro, we could probably use a for next loop. So that's what we're going to be using inside our new macro. We're going to step through each of the characters in the data1 variable, one character at a time. And we're going to use the mid $command to pull out one character from the first variable and one character from the second. And we're building up our output variable. So we'll declare these variables in our function. However, with macros, there is one additional command we will need to put in place, as this macro could be used several times within the same function or subroutine in your code. We don't want to have a collision with the declaration of the local variables. Therefore, we need to use the macro temp command to get around that problem. The macro temp command makes sure that the declaration of long R and str output is unique. It does this by adding a 4-character number onto the end of each of these variables. So when this code is replaced within the body of your code, it will be replaced as long R 0001 for the first time it is used. If we call this macro later on in the same function, it will appear as long R 0002, and everything else within this macro function will have that defined. So anytime we refer to long R, it will be replaced with the long R and the version number of the variable. So for the first iteration, it will be 1, for the second 2, and so on. So regardless of how many times you call this macro within a function, there will be no collision with local variable declarations and no problems with compilation. So as we can see in the code, the output variable is the return of our macro function, which is then returned to the calling function. So we will now output that value to our log and attempt to run our application. So our application has now run, and the output variable contains A1, B2, C3, D4. So we have successfully taken two variables and interleaved the string constants into a new output variable. And we've outputted that to our log so we can see the value. This macro function is a very straightforward and simple function, but it does illustrate what we can do with a macro function. So to illustrate that calling this macro function would have no problems with the declaration of variables, let's call it once more within the same function. But this time we're going to reverse the parameters. We have declared a second output variable, output2, and we're populating that by calling our fold string macro with the parameters reversed, with data2 as the first parameter and data1 as the second parameter. If we run our code now, it will compile quite cleanly and will give us the output reversed. We now have 1a, 2b, 3c, and 4d in our output variable. So we have successfully created a macro function to return a value, in this case a string. You can of course return numerical values as well as string values. So what other kinds of macros could we actually create? One of the things you may wish to use within your application is the use of the Randomise command. The Randomise command is used to seed the random number generator. This seed value can be used to give you a predictable list of pseudo-random numbers. If you want your randomize routines to return values as random as possible, you want to seed it with a value that changes every time. The timer command can be used to do this. But what we're going to do now is we're going to create a small macro as a function to return a randomized seed. And we're going to call this macro random seed. So let's go back into our library and we'll create this new macro function. So this macro is going to return a dword, a numerical value which we can use to seed our random number generator. This macro is going to contain a piece of code which was originally created by Steve Hutchison, one of the titans of the PowerBasic forum, who is sadly no longer with us. So as we did before, we're going to use macrotemp to ensure there are no collisions with the variables we're going to declare. So our var variable is going to be a dword. This is what our macro is going to return. And we're going to be using a bit of inline assembler here to return the value, efficiently and very quickly. Our first command is rdtsc. This reads the current value of the processor's timestamp counter into one of the registers of the processor. In this case, we're particularly interested in the EAX register. Our second command is a swap command. This reverses the byte order within the EAX register. And our third and final command is to copy the data within that register to the variable we have already declared, our dword var variable. This move command quite efficiently moves the value within that register into the declared variable. This is one of the strengths of inline assembler within PowerBasic. You can pass information from registers straight into your variable. and this var variable is what we're returning to the calling function. So when we compile, any reference to the mRandom seed will be replaced by these lines of code. So if we try running the code now, we should get back a nice large dword value. And there is our value on screen. So while we're sending this value to the screen, we would normally use it as the parameter of the randomise command, as you can see on screen now. Calling randomise and followed by our macro. We can attempt to compile that and it will compile quite cleanly. And this will give us a random number. So if we declare a local variable called value, we set the value within that variable using the random command to give us a value between 1 and 20. We can then push that value out to our log. And the value we get is 16. Since the random number generator has already been seeded, we can make a call to the random command once more and get a different value. So first time we're getting 19 and then we're getting 3. So this gives you a very easy way of getting a pseudo-random number. So in summary, what we've done today is we've created a couple of macro functions. These macro functions are set up in an include library with the previous macro functions we did in the last video. This include file can be called from any of your applications and will only add to the code of the executable should the macros be referenced within the body of your code. Macros are a very useful way to save tedious coding, much along the lines of using functions and subroutines in include files. Hopefully you'll find these approaches useful in your applications, but that's it for today. Thank you for watching.